Okay, it is afternoon, so good afternoon, everyone. Uh, I'm Dr. Wes Hines. I'm the Nuclear Engineering Department head here at the University of Tennessee, Nuclear Engineering Department. This is our yearly State of the Department address, although this year we're going to do something a little bit different. Between last year and this year, we changed our administrative structure a little bit, and Jason Hayward is our Associate Department head for Graduate Studies and Research, and Dr. Jamie Coble is our Assistant Department Head for Undergraduate Studies and Service. So I'm going to break our State of the Union or State of the Department address into three segments. I'm going to start off and just give a little bit of a broad overview on really what's changed between maybe now and the last few years. I'm not going to go into nearly as much detail with data and rankings and those types of things. I think right now our focus is more on health and safety and operations of the department. But then Dr. Hayward's going to talk a little bit about graduate affairs, and Dr. Coble will talk about undergraduate affairs. So does anybody have any questions before we get started? Since this is NE 501, the seminar class, I sent out some emails, but let me follow up those emails and just bring you up to speed. So basically, everybody is supposed to attend 3/4 of these seminars. Everybody is required to attend the safety seminar. If you missed the safety seminar, you got an email saying you missed the seminar and that you needed to watch it, write up a one-page summary, and then upload it to Canvas. We had probably a dozen students do that. A couple of students haven't done that yet. And the syllabus says you have before the beginning of the next seminar to actually upload a summary. So hopefully those have been uploaded by this point, because this is when we're starting. Also, when you say that you must attend 3/4 of the seminars, we have 12, I think, scheduled this year. So that means you have to attend 9. At the end of every Zoom meeting, I get an attendance report that says how many minutes each student has been on the seminar. Now, if you've been on the seminar for less than 30 minutes, then I don't consider that attendance. So if you have to get in late or leave early and you want to use that as one of your 9 required seminars, then you need to watch the full seminar and write a summary and upload that into Canvas. So those are, I think, kind of the administrative details. Let's see. Yeah, Sawyer asked, that's just for students who didn't attend the first meeting, right? Yeah, that's correct. If you attended the meeting, you don't need to do a one-page summary. You don't have any assignment to upload anything. It's just that if people don't attend meetings, then I don't have any record that they attended. And the only way that I can show that they attended is have them watch it and then write a one-page summary and send it to me. So that's kind of how I make sure that everybody does what they're supposed to do to take the class. Okay. If anybody has any other questions, you can throw it into chat. That might be the easiest way, since I have everybody muted, and I don't know how easy it is to see if you guys raise your hand. If you jump to the top and I see you have your hand raised. Okay, looks like we're good to go. So I'm going to go ahead and start the presentation. Maybe if I can get my screen to advance. Oh, there it goes. My page down is working. So this is just kind of an introductory page. This is our tagline: study nuclear engineering, save the world. And it could be save the world either due to reducing the carbon footprint, reduce carbon emissions, or it can be related to health physics, using radiation to fight cancer, whether it's diagnostics or treatment, or to fight other things. We actually have a project going on of using radiation to treat the immune response due to COVID. Before they had antibiotics, people used radiation to treat pneumonia. So we can save the world in many different ways. Just, the University of Tennessee, this year, they have this 14-day count, and it looks like we're going to be at 30,000 students, which is the largest we've been. They say, I don't know if it's the largest that we've been in the history of the university, but in the modern era. I think there were some times, before I got here, so before 20, maybe 40 years ago or so, that they were a little bit larger, but having really good enrollment this year, which is exciting. Academic programs, we offer our traditional nuclear power engineering degree at the bachelor, master, and PhD level. I guess at the bachelor, master, and PhD, you can go two different tracks, really traditional nuclear power or radiological engineering. At the master's and PhD, the radiological engineering is called a concentration. It's not really a track, but it's kind of like a track. We offer several undergraduate minors. We have a brand new minor starting this year in nuclear safety. In addition to the minor in nuclear safety, we have a graduate concentration at the master's and the PhD level in nuclear safety. And that really got started because some of our partners said that no one really teaches anything specific to nuclear safety, and there's a huge need. And they partnered with us to, develop the curriculum and help teach that. We have a professor of practice, Chip Lagden, which is a safety expert. He used to, I think, be kind of the chief of safety for DOE. And he teaches our licensing class for us. So we have a strong partnership there. We have nuclear decommissioning environmental management. We started that a few years ago, a very strong minor. I think we have maybe 18 students taking that minor, and some students report back that they got their job because they had that minor. EECS offers the principles of cybersecurity. We've long offered a reliability and maintainability engineering minor and master's degree. We have a graduate certificate in RME. Also new this year, we have a Master of Science in Medical Physics, and we have a couple graduate certificates that we've had for a while, the Maintenance Engineering Graduate Certificate and the Nuclear Security Science and Analysis Graduate Certificate. If you have any other questions about that, you can contact me offline or contact Dr. Hayward. I always show this picture of our faculty. Right now we have 6 full-time research faculty. I think that's the most full-time research faculty we've ever had in our department. We have 5 of our faculty who have retired and are either emeritus or have moved into new positions, research positions, or teaching positions to continue on. So those are in the lower left-hand corner. And then we have our current tenure and tenure track faculty. So we used to have this slide on the left-hand side. There were 7 faculty members, the 5 part-timers down there, plus myself and Dr. Ruggles, and that's who we had in 2007. And then I say, and look who we have today. So that's basically the story that I want to tell here, is that we have really grown. The university has invested in us, and we have been very successful. There's our fall enrollment data. This data we get from ASEE, and they don't have the 2019 data on their website yet, which I'm kind of surprised with. But our PhD enrollment maybe went down a few. Our undergraduate enrollment is still close to 200. Again, they take this 14-day enrollment, which will be coming up real soon, and that's what the university uses as the actual enrollment. But you can see what's happened over the last decade is that we've really transformed ourselves from maybe more of a master's degree graduate program to a very strong graduate degree PhD program, and in fact have the largest PhD program in the country in the history of the United States, I think 5 years running now. And this just kind of shows our bachelor's, master's, and PhD enrollment numbers compared to the other top 10 nuclear engineering departments across the United States. And you can kind of see where the PhD program aligns with some of these other top 10 nuclear engineering programs. Again, ASEE only has their fiscal year 2018 data up. We were #1 in PhD enrollment, #2 in total enrollment, #2 in BS enrollment, #1 in PhD graduates. So, and our faculty isn't that large. We have 16 or 17 faculty. You have some departments that have 20 to 25 faculty. You're looking at Michigan and NC State has grown rapidly recently. So our students do a fabulous job, especially if you look at, per FTE, per full-time equivalent faculty member, the amount of work that our faculty does, it's fantastic. Our new freshman class of 2024, we have 55 freshmen, so that's not our largest freshman class. I don't think we've ever had 60, but we've had, maybe a few more than what we got this year. We have 15 females, which is fabulous. And what I think is interesting is if you just look at the geographic diversity of our new students, 36 of the 55 are from Tennessee and 19 are from other states, 4 from Virginia, 3 from Illinois. But the University of Illinois is wondering why they're coming down here, but we're happy to have them. And all the other states where we have new students coming in. That's fabulous. Research expenditures. I just looked at the numbers from 2020. It looks like we're really flat from where we were last year, which is great because we lost a faculty member and when Steve Skutnik went back to Oak Ridge National Laboratory. So for us to get a little bit smaller and continue to do as much research as we've done, that's fabulous. It's these research dollars that fund the graduate students to do all the great work that they do. And research expenditures per FTE, this year will probably be up, close to $900,000 per faculty member. The college average was 486 in 2019. So we almost double what the average College of Engineering. If you took us out, I'm sure, the college average would go down and we double the amount of research that any other department does. Student data, our bachelor's degrees, we're happy if we graduate about 40, and that's kind of where we've been lately. Our master's degrees, it's not our focus, but I know in 2016 when we had 33, we were the most in the country, and graduating 20 to 30 is fabulous. PhDs granted, we had the most of all times back in 2018 when we graduated 23, and last year we had 11, and that's fabulous. 20% of our graduate students are female. Hope that continues to rise. Okay, let me jump off away from data and talk a little bit about new facilities. We're really excited about the new engineering complex. I'll show some pictures of where it stands right now, but it's going to be open next year, next academic year. So we'll be moving in at the end of next summer, which is fabulous. We'll move our staff in first, then our faculty and students to follow, and then our laboratories to follow that. Our staff is our #1 priority there. They have to get there so they can support the rest of us. We're going to double or triple our research space that we had when we were in Pasqua. That building on the lower right is Pasqua Nuclear Engineering Building. It was built in 25. It's now gone. The one on the left there is Estabrook. It was built in the late 1800s and it's now gone. The new facility has a budget of about $130 million, and they're on time and within budget. We began this design, 3 or 4 years ago. We got relocated December a couple years ago. They started demolition in March of 18. They demolished it fairly quickly, a couple months. By that summer, it was demolished. Began construction in December of 18 and completed construction in hopefully June of next summer. Sorry, having some problems. I jumped over to chat to see what the chat came in and couldn't get controls back to PowerPoint. So this is the artist rendition of the front of the new building. So this is what's facing north. It's going to be a beautiful building. We'll still have the bridge that goes to Tickle right there on the left-hand side. This is the view from the back. Basically, the building's built in like 4 quadrants. These are 2 quadrants that kind of stick out. This one on the left, up on the 4th floor, is going to be the dean's offices and all the Tickle College of Engineering administrative offices. And then the floors below that are engineering fundamentals and freshman engage. On the right-hand side, this part that sticks out is all the faculty, staff, and student offices, some classrooms, a simulator room, cluster room, and then kind of in the back, on the back left, is more engineering fundamentals. On the back right, it's nuclear engineering laboratories, and kind of in the back at the top of the couple floors, it's flex research space that's used for college research laboratories. This is a picture, I think, from yesterday or the day before. You can see that they're putting brick on, so the exterior is getting, it's not sealed up yet, but they're getting the bricks laid. You look on this right-hand part, these two on that first floor that's off the ground, there's 2 rooms there. Those are actually small student collaboration rooms. If we go up a little bit, there's the A&S, really just the A&S, American Nuclear Society Student Complex, or just our student societies complex. And they'll have their own conference room. You can move up a little bit more, there's another conference room. And then you get up to this 4th floor, and there'll be a boardroom, and there's going to be a nice balcony there. That'll be the nuclear engineering balcony. If you look down to the right, this goes into our high bay, and behind that are some shielded facilities. So we have 32 faculty offices, 20 postdoc offices. We have enough graduate student offices for about 90 funded students. It's not as many. I mean, if we have 150 graduate students, we can't put them all in there, but we have a lot of people that might be working out at Oak Ridge, or some people that might have their graduate offices in their laboratories. So that should be good enough. We have some classrooms, meeting rooms, break rooms, study rooms, electronic shop, mechanical shops, and 23 state-of-the-art laboratories. These are just some pictures. There's this nice staircase that goes through the middle of the building, and it's kind of the thread that ties the whole building together. It's going to be beautiful. We have, here's the list of the 23 new research laboratories, an accelerator room, power plant simulator room, all kinds of fabulous new spaces. There's a picture when they were pouring the shielded vault walls. That wall there that's kind of straight in front of us is a 5-foot thick concrete wall. Really exciting to watch them build that. We have a Varian linear accelerator, plans for a fast neutron source. We're in the midst of ordering our neutron generator. We may have actually 2 of them. Approach to critical will move over there. The graphite pile will come back from across the river and move over there. So we'll have all of our facilities here together. I'm happy to, let's just hold all the questions to the end, and I'll pass off to Dr. Hayward.
Thanks, Dr. Hines. Can you all hear me?
Yes.
Okay, great. So I'll go ahead and start talking about our research program, though. Just a moment. Let me get rid of this box. So the faculty meet every so often and talk about what our research focus areas are going to be as part of our strategic plan. And that includes nuclear reactor fuels and materials. It includes nuclear security work. It includes radiological sciences and health physics, where a big focus for some time now has been space radiation work, including work from Dr. Heilbronn. And so another one of our focus areas is nuclear instrumentation and control, reliability and safety, focusing especially on advanced reactors. We do work on nuclear fuel cycles from cradle to grave, as illustrated by this picture. We also do work on nuclear fusion technology. We have a number of faculty that work in that area, including work on ITER and in collaboration with Oak Ridge National Lab, especially taking advantage of our expertise in reactor fuels and materials, and specifically plasma materials interactions. We have growing work in advanced modeling and simulation for sure. For a number of years, that's included work with a consortium for advanced simulation of light water reactors based out of Oak Ridge. And we have a lot of work in radiation detection and measurement as well. So here are the faculty that work in these areas. One of our biggest ones and continuing to grow includes nuclear reactor fuels and materials. Recently with additions of Professor Brown and Professor Sobes. We have a lot of work in nuclear security, including Dr. Hall, myself, Dr. Halbron, Dr. Lucosi, and the list goes on. I guess I shouldn't read every name. So we have a lot of work in radiological science and health physics, including Dr. Halbron's work. We have a continued investment in instrumentation and control, reliability and safety. We've got work in nuclear fuel cycles, 5 faculty contributing in that area. Nuclear fusion technology is certainly one of our focus areas with 3 faculty working in that area. We've continued to add capability in advanced modeling and simulation, including addition of Dr. Sobes recently. And then we've got 4 faculty at least working in radiation detection and measurement. Dr. Hall does some work in that area too. And so you can find out more about some of the work that's going on our website, or through just reaching out and talking to faculty. That's the best way to keep up with what's going on if you're interested in a particular research area. So let's say as an undergraduate and you want to get involved, just reach out with some frequency. We'd be happy to talk to you. So I'll just give an overview here of some of the research in nuclear reactor fuels and materials. This is certainly some world-leading work going on in this area. So I include here some themes and some accomplishments, and some pictures of some of our activities at Wright. So some themes include metallurgy of structural materials, ion and neutron irradiation, looking at different size scales from the kind of the micro to the macro for sure, and different forms of fuel. There's TEM work, there's fusion and space fission work. That's been a growing area lately. Space reactors and just space research in general. There's computational modeling and measurements of radiation effects of materials going on here. And of course, radiation damage and high pressure studies as well. So there's some illustrations here at Wright of some of the work going on in modeling nuclear fuel and some of the more TEM-based investigations and microscopic investigations. And then we have a lot of work in extreme conditions research, including work from Dr. Lang, for example. So we're working individually, we're working as part of a consortia and accomplishing a lot in this area, including modeling fuel failures at commercial nuclear power plants that provides new understanding. We've increased understanding through assessing radiation performance of new materials of various types. You can read some of the types here. We've developed advanced characterization methods that employ new methodologies and take advantage of facilities at Oak Ridge, like neutron scattering, to show what can be done with new capabilities. And we're providing new insights into defect formation and disordering mechanisms in nuclear waste forms. So those are some highlights. In nuclear security, we've got a lot going on as well in these application areas, which include detection, counterproliferation, detection and response to radiological and nuclear threats, forensics, radiochemistry, and other security type applications. And so we're looking at gamma rays, neutrons, slow, fast, muons, improving theory, methods, algorithms, quantitative analysis of data and images, lots going on. And so there's some illustrations here at Wright of some of the work we've had going on in recent years, including quite recently from Micah Folsom and Oak Ridge National Lab, demonstrating the first single volume neutron scatter camera with imaging and spectroscopy capability that could work in near real time. We've demonstrated adding fast neutron sensing to a mobile trailer-based rad and nuke threat sensing platform to add value to that. Historically, you could just drive by a source and see gamma rays and image the source, but adding neutrons means you can look for shielded plutonium potentially as you pass by too. Or we've worked on other platforms like smaller scale directional backpacks combined with vision and things like that to advance capabilities for search. Dr. Lucosi's done a lot in neutron imaging as well. There's an illustration at right of some of the work that he's done and demonstrated in constructing and showing the first ever solid state semiconducting cold neutron imager using lithium indium diselenide, which got a lot of visibility and produces some cool images. So talk to him for some more information. At the same time, our work in nuclear security is enhanced through our partnerships that are brought forward, especially by our Institute of Nuclear Security. And so this promotes collaboration in various areas, technical and otherwise, helps solve real world challenges, develops education, works with operational folks, to really have a multi-pronged approach to improve nuclear security in the country and in the world. And so we're working with our partners in the region, including Oak Ridge National Lab, Y12, ORAO, and the Baker Center on the policy side of things to push forward lots of different areas. Okay, so we've got work in radiological sciences and health physics as well from various faculty, especially Dr. Halbron in this area. Themes include radiation physics, transport, shielding, risk assessment for space applications especially, and also for terrestrial applications. We've ramped up on medical isotopes. We're certainly ramping up in medical physics. Proud to start that new program this year. And we're doing detector development for physics, for medical, for space and industrial applications. We're doing work in neutron science, especially in partnership with ORNL. And we're doing work in nuclear battery development for various applications as well. And so you see at right some highlights of certain accomplishments, like development of the highest resolution neutron imaging fiber for cold neutron sensing with 15 micron resolution. For the second target station, Dr. Lucosi and I are trying to drive forward advances toward 1 micron resolution. So there's still a ways to go there. There's measurement of thorium and actinium production cross sections from proton and neutron bombardment. Thorium-230. There's other work with actinium that a lot of you have heard about, which is promising for medical treatments, targeted medical treatments in the future. There's 3D diamond work as illustrated here in Dr. Lucosi's group for in situ alpha spec. This also includes work for actinium alpha radiotherapy, which could be impactful for leukemias of various types. And then of course, Dr. Halbron's work is very impactful in light ion cross-section measurements from various ions, including iron and oxygen. There's a lot of publications that have been done in that area with high impact to provide new data, especially for understanding space radiation environments. So some cool stuff going on. And I continue on the radiation detection and measurement. We broke this out as a separate area. Really, there's some overlap with nuclear security, but it doesn't all go into nuclear security. So here we talk about our world-leading inorganic scintillator growth and characterization, where that center in SURF is led by Dr. Chuck Melcher, certainly one of the best in the world. And that is one of the best academic centers in the world for that type of work. There's semiconductor characterization and packaging, especially going on in Dr. Lucosi's group. We're making glasses for neutron imaging and gamma sensing. We're making sensor systems for various particle types, as I mentioned, new algorithms, and impacting lots of different applications as we do this. So the impact is felt from Homeland Security with the new scintillators that are being developed, especially with high energy resolution. We're pushing the limit and trying to achieve 2% energy resolution and to try to grow these more quickly so they can be produced inexpensively. So there's lots of promising scintillators that have been developed, including this one that's pictured, a potassium strontium iodide, which grows very quickly with high energy resolution, and we're working on understanding these and how they can be applied. There's also, again, the lithium indium diselenide, which has very high slow neutron sensing performance and has promise for various applications too. We're also pushing forward imaging capabilities for DT generators, for tag neutron imaging that can be used to image nuclear materials, understand elemental analysis. We've done some of the first work on gamma ray LiDAR. You've heard of LiDAR used in self-driving cars. We've done gamma ray LiDAR work to show how it would work up at 6 or 9 MB or above. And we're also working on quantifying neutron source strength from images. So we're doing a lot of work in I&C, reliability and safety, one of the only departments that, nuclear departments that has a lot of focus in this area, including work from Dr. Jamie Coble and Dr. Richard Wood, especially. So some leading work in process monitoring, in equipment condition assessment, fault detection, diagnostics, and prognostics for various applications. This theme area prepares a lot of students for work in industry, especially, and in research. So we're doing nuclear instrumentation and controls for Gen 3+, small modular reactor and advanced reactor designs. We're addressing regulatory issues in I&C, risk assessment and defense in depth, especially with Dr. Wood's help. And so some of the pictures of our accomplishments are at right here, with flow characterization for integral primary systems and non-circular flow paths. Dr. Brown's advancing our work in that area especially. New instrumentation and control strategies for integral inherently safe LWR, as pictured down here at the bottom. PET tracking for measurement in opaque flows and complex geometries. And then advanced monitoring and control algorithms. Lots of algorithms work to support autonomous operations. We're doing work in fuel cycles as well. And so some highlights are here. We've had a lot of focus, for example, on molten salt systems, which are certainly one of the systems in the future where there's a lot of investment. There's also work in in-core fuel management, various advanced reactor designs as shown here, waste management, and we have a lot of accomplishments in these areas, including transition analysis from current US open fuel cycle to more sustainable fuel cycles, advanced modeling and analysis of long-term fuel storage and dry casks. We've also done work in muon imaging for assay of those casks. There's neutronics modeling going on. There's lots of contributions to new codes being developed at Oak Ridge National Lab, like the scale-based system, especially by Dr. Skutnik. And there's been work in pin-by-pin isotopic tracking, as illustrated at right, with full core operational environments over the whole life cycle. That's what we're looking at. There's been a lot of investment here in nuclear fusion research to try to make this a viable technology in the near future. So themes include advanced computational modeling, led mostly by Dr. Brian Worth. There's also experimental characterization of plasma surface interactions from the team here, structural material response and such, because the main problems in fusion are really materials problems. And this team is, working on diagnostics, working on solving these problems so that hopefully within 10 years we can have fusion as an energy source. Teaming up with small companies and trying to make it work in collaboration with our students who are, of course, working hard in these areas too. So some of our accomplishments include experiments and modeling of the tungsten surface response for low energy plasma exposure, developing laser-based diagnostics. So we've got experiments going as well to push the state of the art. And I should probably move on to advanced modeling and simulation. So in this area, there's tons going on and it's growing still. Our themes include computer methods development for reactor physics, nuclear data, especially with Dr. Sobes on board now, and nuclear crit safety and uncertainty as well. That's an area for Dr. Sobes and Dr. Maldonado. So we've got AI autonomous system design of nuclear systems, including work from Dr. Sobes as well, computational modeling and measurements of radiation effects of materials from this team, reactor thermal hydraulics, especially from Dr. Brown, liquid metal flow, heat transfer, cavitation, and fluid transients. So we've got work going on from Dr. Chavala as well, especially as it pertains to MSRs, and then development of new tools for high fidelity used fuel assembly, source terms, including origami. So we've got code development from Dr. Maldonado, Dr. Worth, and so on. So some accomplishments are listed here and illustrated at right, such as the modeling for SMRs, LWRs, understanding the impacts of crud deposition on nuclear reactor performance, evaluating fracture toughness, and some benchmarking work that's illustrated here. Again, if you want to learn more, please reach out to our faculty. And I wanted to highlight some important things for new students here. I want to say again, we'd like you to be applying for external fellowship opportunities. This shows that you're able to support your own work as graduate students, and it's attractive as a researcher if you can apply for and get some funding for yourself, even if you already have a GRA position like a lot of you do. So we tend to have a lot of success in this department. In NEUP fellowships, talk to your advisor about applying for this. It also tends to give you a higher stipend, so that's not bad for you either. Let's apply for a lot of NEUP fellows this year and win a lot like we usually do. There's SCURA fellowships, like one of the new incoming students has an NNIS fellowship. There's Rickover fellowships that we've had before as well, supporting students in the power area. So look up SCURA and see what the deadlines are. We should be applying for NSF graduate research fellowships. They're very competitive, very prestigious. Get your mentor to help you out. There's stewardship science that's due on January 8th. Some of us work in stewardship science and our students can be competitive for these applications. And this is not comprehensive. There's SMART, there's NASA. I had a NASA fellowship going through school. There's DOE science. There's ANS. I know that helped me out going through school too. You know, if you don't apply for these scholarships, you don't know if you're going to get them, right? There's SWE, and the list goes on. So talk to your advisors. Many of us have received these types of fellowships and have helped our students apply and have some successful applications. Then just really quickly, I wanted to talk about the handbook that's been updated this year for your use and reference. So the new handbook talks about the medical physics program. If you want to know more about that, look at section 7.3. If you don't know where to find the handbook, go to our website, click on the graduate program, then the overview, and then click on this link, download the handbook, and you can find these sections. There's information on the medical physics certificate, which is really only for students with a PhD, and the new graduate concentration in nuclear safety is in section 7.6.6. Now, a concentration doesn't require any extra classes, so you should keep that in mind. That's nice to have if you want to work in the safety area. Also new in the graduate handbook, you should look out for this through the link, are the student and mentor expectations in section 5. This is new this year, and if you are new this year, your advisor should be discussing something specific for you in this area of expectations. Also, what expectations should you have of us? That's covered too. Graduate student support is discussed in section 5.3. For example, NEGSA and the support that provides. And there's more than just that in section 5.3. There's a new section on the PSD process and all the forms you have to fill out at various times. So if you want to know how that works and when you're supposed to be turning in certain forms, check out that section. For example, you should know that the PhD candidacy form is not turned in until after the PhD proposal defense. That section will tell you how it all works. There's also a section for the master's process and the forms that go along with that in section 7.2.2. There's clarifications of some common graduate student misunderstandings, such as the comprehensive exam and what that is about in 2 parts. That's in section 6.2. There's more information on fellowships, but it's not comprehensive. There's information on combined MS defenses and PhD proposals. And Dr. Hines and I also want to emphasize to everybody, that all students are graduating under the current catalog. And the information from our current catalog is in the graduate handbook, so you can look it up there as a convenient reference. Another quick note, is that for those of you interested in certificates, you need to declare that prior to completion of 6 hours of work, on the certificate, and 1 extra course is required. So keep that in mind. Lastly, I wanted to talk about this year's new graduate class. So this year we have 35 new students as of the fall. As of the spring, there's going to be at least 39. And this doesn't yet count the Bredesen Center students, so we'll know about those within a couple of weeks. We've got 11 women out of our 39. We'd like to increase those numbers further. We've got 3 international students. That just counts folks coming in from outside the US, not those that are already inside the US. 2 African American students. We're looking as a department to increase these diversity numbers as well. We've got 8 new medical physics students, 7 military veterans we've added. We tend to have a lot in this department. As far as things that I know of, 1 external fellowship, although if I've not covered you, you can let me know you're a fellowship student too. We have an NNIS fellow, but lots of you hopefully will apply for fellowships and we'll have more to count. And that will be something you can list on your CV. And so far we have 19 declared PhD students. So the last thing I want to say is, if you're a master's student and your ultimate goal is a research career and or a PhD, please talk to your advisor, talk to me about switching to the PhD program with a concurrent MS. And I also wanted to say thanks to Dr. Brown for helping to put together the grad handbook. And that's all I've got. So we'll let Jamie take over. Do you want to share your screen, Jamie?
Okay, hopefully you're all looking at my screen. And I have one question that I'm gonna ask you at the very, very end. So if you want to take a moment to go to Slido and enter the event code Z482, or take a picture of this QR code with your phone, then you'll be all set up when we get to the very end and want to do a very, very quick poll. So as Dr. Hines said at the beginning, I'm the new associate head for undergraduate studies and service, and I know that this is primarily the graduate seminar. And so, there we go. So I'm going to talk a little bit about the undergraduate updates, but I don't want to belabor that too much. But just in case anybody's curious, or if we have any undergraduates on the call today, we have updated our curriculum from last year to this year fairly extensively. We dropped several of the out-of-department classes that were prerequisites for some of our courses, and we found out by talking with our students really weren't meeting the needs of our classes. So the materials information that we used to get outside of department from material science and the mechanical engineering programs, we've pulled all of that into a new course offered within nuclear engineering that's really focused on radiation effects and materials issues specific to nuclear power and nuclear applications. And so we got rid of MSc 201, we got rid of ME 321, and replaced it with NE 340. We dropped the circuits class out of electrical engineering and computer science because we found that students weren't being prepared the way that we wanted them to go into our radiation detection labs. And so they weren't necessarily getting a lot of value out of that class. So we dropped that. Dr. Lucosi created a brand new sophomore level class that would introduce some core concepts in statistics and error analysis, linear algebra, solutions to differential equations and some partial differential equations, and introduction to some computational tools to really help all of our undergraduates be set up for success in their junior and senior year. And then with all of these curricular changes, it opened up a spot in both of our tracks, in the traditional and the radiological track, to have an extra technical elective. So right now our students take 3 technical electives, which really supports going after one of the minors that Dr. Hines talked about without having to add a lot of additional classes into your overall curriculum. And then finally, we kind of shuffled a few classes around to try to balance the load if you went through our undergraduate curriculum, you know that the junior year is a very, very heavy year, and we're always looking at ways to kind of move information around so that people are maybe learning things in an order that that kind of eases the burden, or like I said, kind of opening up some opportunities to really specialize in a different way. We already mentioned the new programs we have focused on nuclear safety. So again, I'm not going to belabor that too much, but there is an undergraduate minor in nuclear safety or a master's degree concentration, which is different than a graduate certificate. But as Dr. Hayward said, you can complete that concentration without adding any additional classes to your course plan. And if that's something you're interested in, I would strongly recommend you talk to your advisor, because there are some specifics that you need to be careful to make sure that that you're meeting all of the requirements of the concentration and the overall requirements for the master's degree in general, so that you don't end up having to take extra classes. But that's a new program and a very unique program to the University of Tennessee. Okay, so what I really wanted to talk about to this group, more so than our undergraduate curriculum, is some of the new initiatives that we have in the department. So hopefully everybody saw in January, maybe January 1st, the beginning of January, the pledge that came out of the department for allyship, social justice, diversity, and inclusion. And if you haven't seen it or you just want to read through it again, it's on our website. You can go to this link and read through it and see what we have already committed ourselves to do to address some of the inequities that we see in higher education, in the nuclear industry, and just in general. One of the first actions that we've already started is establishing this diversity, equity, and inclusion action committee inside the department. So we held, as part of this, a department listening session on August 18th. And I think we had maybe 65 or 70 people join us for that listening session. And we had participation across the board from undergraduates, graduates, staff, faculty, researchers, people outside of the nuclear engineering department who just wanted to contribute. And so we got a lot of great ideas there, identified some of our key priorities that include awareness and training of issues surrounding diversity, equity, and inclusion challenges, faculty hiring and student recruitment, and how to look at those through a DEI lens and really improve our practices there, developing and really strengthening our department community and culture, and then transparency and how we measure these things and our metrics and how we report them out. At this point, we're forming the DEIAC, and if you're interested in getting involved, you can still sign up. I think you can always sign up, but if you go to the tiny URL there, tiny.utk.edu/NEDEIAC, then there's just a quick Google form that you can fill out to show your interest so that you're on our mailing list. And we will be having our first committee meeting tomorrow at 1 o'clock. But if you're not available to join that, that's okay. We'll be scheduling future committee meetings later on to make sure that we get everybody who's interested involved. I did want to show, we've got, of the people who've already expressed their interest in joining the DEIAC, almost half of those are graduate students. And so I just want to thank you all for, stepping up and showing your volunteer spirit to really kind of take some time out of everything that you're doing as graduate students and your coursework and your research, and trying to build a better community in our department. And so thank you. And again, if you're interested and haven't signed up yet, please do. We'll be glad to have everybody involved in that. Another one of our commitments is to provide additional opportunities for open feedback, kind of at any point from anybody who has anything they want to talk about. As part of that, we've added an additional department town hall. So for the last many years, we've had one town hall meeting during our seminar series in the spring semester. Now we're going to have one in the fall semester and the spring semester. I'm pretty sure that this semester it's scheduled for November 18th, which would be the last Wednesday of the fall classes. And then we'll have one at the end of the spring semester as well. We have always, or for a very long time, had senior exit interviews with all of our graduating seniors. And that's where a lot of the input that we get that leads to curriculum changes comes from, and some other changes as well, is really sitting down one-on-one with every single student and getting some feedback. And so one of the things we want to do is try to extend that so that we're not only talking to the graduating seniors, but talking to anybody who might have something they want to share with the kind of the department leadership, so that we can make sure that changes happen where they need to. And so we're really looking at trying to formalize an opportunity, which would not be a requirement, but would give you an opportunity to have a retention meeting. So you're not ready to graduate, you're not planning to leave, but you just want to check in with somebody. And right now we're thinking that the Dr. Hayward would meet with the graduate students, and I would meet with the undergraduate students. And we're still working on kind of how to formalize that process and what that would look like. But at any point, if you have anything you want to discuss, always feel very free to reach out to either of us, to Dr. Hines, to any of the faculty. And we're also working on getting an anonymous suggestion box onto the department website, so that if there's something you want to report or suggest, but you don't want to be directly tied to it, you would have an opportunity to do that. The graduate students also have access to our university ombudsperson, and that's Dr. Lisa Yamagata Lynch, and she will be coming to give a seminar in a couple of weeks. And so she'll tell you all about what her office does and what you can do if you need to get access to that. Some other opportunities outside of just what we're doing in our department that are really more focused on community and culture. And I forgot to add one. The college has an anti-racism and allyship task force. And if you're interested in getting involved in that, please let me know, and I'll get you connected with the chair of the task force, and she'll get you all signed up. But we also have this evening, tonight, the next kind of a follow-on to the Summer Rocky Topics on allyship and anti-racism. So from 5:30 to 7 tonight, there'll be just a university-wide discussion about what we can do as a university and as part of the Knoxville community to really build up the community that we're interested in. I would also urge everyone to sign up for Safe Zone training. Safe Zone training is offered out of the Pride Center, and there are 2 tiers. So tier 1 is educational. Tier 2, I think, is starting to get more towards actions that you can take to really provide a safe space for people who identify in the LGBT plus area. The other, we're in a voting year. So if you are if you're a person who's eligible to vote, then I urge you to make sure that you can vote and that you're registered to vote, you know how to vote, especially if you're not a permanent resident of Knox County. And so there's a Vols Vote initiative going on right now. And if you go to the UT calendar and look up Vols Vote, you can find all kinds of information. They're having workshops to make sure you're registered to vote, to find out how to get an absentee ballot if you need one. And then just some informational sessions and film screenings and things. The College of Arts and Sciences is hosting a bi-weekly college conversation series focused on allyship and anti-racism. And so you can go to their list, and I'll make sure all of these links get on Canvas if you want to look at them later. But you can look at their list of events, and then all of the previous ones have been recorded, so you can always go back and watch them later. And then finally, it's time to, if you're interested, if you're so inclined, to sign the 2020 Pride list, which again comes out of the Pride Center. And so now here's where we go to Slido. So the last thing that I wanted to mention is that we're looking at how we can do some stuff as a department. Normally we have a welcome picnic. We have department activities throughout the the school year. We have college activities, you know, and we're all on campus and we get to see each other. Obviously, we're not doing all of that right now. And so we were trying to think through some things that we could do as a department to really spend some time together, have a chance just for students to relax and get to know each other, get to know the faculty and the staff in the department. So some of the things that we've thought of is a virtual game night, movie night, team trivia, family feud. We're trying to figure out how we could poll the department to do a family feud style. You know, we asked 100 people, top 10 answers are on the board kind of thing. Or potentially some socially distant but in-person activities like a bring your own picnic, and then we would provide some music and some safe games that we could play. And so that brings me to the Slido thing, if I can. So if you manage to get onto Slido, there should be a poll up just to see if any of these sound like something you would like to do, or if you want to suggest any other ideas, you can do that on Slido or in the chat. If we've got anything, if you think of something later, or if you're involved in a group that really has a great idea, but you think, man, I don't want to have to be in charge of planning this whole thing, I could use some support for that, then you know, let us know. We're here to help you come up with some ideas, and also to help you with planning, make sure that all of the safety protocols are in place that we need. And then the last thing I'll mention is that we do have a department Slack. If you haven't joined the Slack yet, please do. Dr. Hayward has posted a whole lot of outdoor activities that, you know, if you get a small group of people together, would be very safe to do. And so you can join the department Slack from this tiny URL as well. So with that, you know, it looks like we've got interest in some of these, maybe in having a game night or a trivia night, or even a picnic that maybe we could do on campus somewhere in Ayers Lawn or the engineering quad. So we'll definitely look into those things, figure out the best way to set them up, and be in touch so that everybody who's interested in participating can. But that wraps up everything I wanted to talk about. And I don't know if anybody, Dr. Hines, has any more.
Thanks, Dr. Coble, and thanks, Dr. Hayward. A little bit of background about why we're trying to have these social activities is that, you know, a lot of students came back to campus. They were excited to be back and to meet people and be able to socialize with people. And then, you know, then you have to think about the COVID and COVID and CDC guidelines. And a lot of students are then finding, you know, maybe they don't have COVID and they don't have close contact, but they're still isolated. So we're trying to find ways to help students have a college experience, you know, during COVID. So that's our goal. We want to make sure that you have social opportunities, that you can meet each other, so that you can engage each other, and so that you can do it in a safe way. So, you know, if you have ideas, please bring those ideas to us. The department's willing to put some, you know, money into some resources, whether we have to buy cans of Coke and prepackaged potato chips or whatever, just something to help out and to give people a little bit of a college experience in these tough times. We're almost out of time, but I'm going to open up for anybody that has any questions. I think I can come in and just like unmute all. So if anybody has a question, you can unmute yourself and ask it in the next couple minutes.
Dr. Hines.
Hi there.
This is Mairead. On the slide that you had where you had the new tenure track professors, we used to have 2 positions open, and I thought I saw a new face, and I may have missed when you made the announcement as to who that was, but now we only have 1 position open. Is that Dr. Bogadic?
Yeah, that's Sandra. She's going to join us in January. So we do have a new faculty. Thank you. I probably should have pointed that out, since that's a major addition to our faculty. We're excited to have her come join us. She'll be starting in January. She graduated from Berkeley. she's taken kind of a semester to get acclimated. Her husband has a job out there, and you know, looking for opportunities for him maybe at Oak Ridge. It's kind of tough to relocate now when people aren't doing a lot of interviewing and those types of things. So happy to get her and let her have a little bit of a later start. Also, when I mentioned our new initiatives in nuclear safety, it's Bechtel that's the company that's helping support us. They're the ones that are loaning us our professor of practice, and have really started that new area of education for us, or at least putting more emphasis into it. So I want to give a little shout out to Bechtel.
So a question, in terms of like the nuclear safety concentration, like I took the licensing class when it was listed as a 597.
Right.
I see in the handbook that there's a new number for it now. Would I still be able to count it towards the concentration if I took it under a different course number?
Yes. Yeah, you can. And I think one of the challenges that some students have are they take something for undergraduate credit, and then they get into graduate and they're like, well, I want to get that concentration or that graduate certificate, but I've already taken something for at an undergraduate level. What we usually do there is we allow you to choose another class that we will substitute in for it, which kind of gives you credit for that class. We don't want anybody to take something as an undergraduate and have that not allow them to get some other degree or certification at the graduate level. So, your major advisor or myself or Dr. Hayward can certainly help you work through that.
Thank you.
Okay, we're a couple minutes late. Thank you for your time today. I wish we could all go downstairs to the second floor and have some refreshments together, but we can't do that right now. I look forward to seeing you all next week. For everybody, if when you sign in, your name comes up, try to make sure that name is a name that you register with so that I can make sure I have your attendance correct. Thank you and have a great evening. Bye-bye.